In this video, I will discuss a JEE Advanced PYQ based on projectile motion. First, I will highlight some important points. Projectile motion is a mass thrown from the surface of Earth. This is the Earth's surface, and there is a mass here, and it's projected with a velocity u at an angle, say theta. So the motion of this object, the trajectory will look like this. So this is a parabolic path. And it's inverted parabola. This distance covered in the horizontal direction is called range, and the time it takes to go from here to here is the flight time t. So this range we can obtain as the x component of the velocity u cos theta. This is the initial velocity, and in the horizontal direction or in the x direction, horizontal direction is x and vertically up direction is y. So in the x direction there is no force, because the only force acting on this mass is gravity due to the earth. So since there is no force in the x direction, acceleration in the x direction is 0. So velocity in the x direction is u cos theta throughout. So the range is the constant velocity in the time it takes to go from here to here. That's the flight time. To get the flight time, we can use this vertical motion from here to this maximum height point. This is the maximum height point. So by symmetry, the time it takes to go from here to here is t by 2. And remaining t by 2 times it takes to go from here to here. So if you know this time, the time to go from the ground to the maximum height point, we can find this t, flight time. So to get this t by 2, we can use vertical motion, v equal to u plus at in the vertical direction. Y corresponds to the vertical component, plus a, and then t, and t is t by 2. And this acceleration is because of gravity, so this minus g. And this final velocity at the maximum height point, this equation will apply at this maximum height point. So there the velocity is 0, and the initial y component of the velocity is u sine theta. U will have two components, u cos in the horizontal direction, u sine theta in the vertical direction. Minus g t by 2. So from this I'll get the time of flight t as u sine theta by g into 2. So once I know the flight time, I can put it here to get the range. So now the range will come out to be u cos theta into u sine theta by g. Okay. Another thing is the average velocity. It's a basic concept. Average velocity is defined as total displacement by the total time taken. So if I take these 2 points, the starting point and the point where it hits the ground, and find the average velocity within these 2 points, it will be like the displacement will be the range of the projectile, and the time is the flight time. So with this basic understanding, we should be able to solve this JEE advanced question. Let me go to the question now. This is a question. You can read it. A ball is thrown from ground at an angle theta with horizontal with an initial speed u0. For the resulting projectile motion, the magnitude of average velocity of the ball up to the point where it hits the ground for the first time is v1. After hitting the ground, the ball rebounds at the same angle theta but with reduced speed u0 by alpha. Its motion continues for a long time as shown in the figure. If the magnitude of average velocity of the ball for the entire duration of motion is 0.8 v1, the value of alpha is. So this is how the motion looks. The projectile starts from here, hits the ground and rebounds. So while rebounding, the velocity is reduced after rebound by a factor alpha. So obviously since the velocity is reduced, it will reach a lesser height and a lesser range. So it keeps continuing. Each time it rebounds, the velocity drops by a factor 1 by alpha. So you have to find the average velocity between this point, last point. Okay. And they are given with the average velocity between this point is v1. It's not a difficult question. You can pause and run this question. So let's take this from here to here. Let me call this range of the first part of the projectile motion r1 and let the corresponding time be t1. Okay. So the average velocity between these 2 points is, they are given in this question as v1. That's equal to the displacement between these 2 points, that's r1, by the time taken t1. Okay. So the range is the horizontal component of velocity, which is u0 cos theta into the flight time t1, because the range is the horizontal motion distance covered, which is a uniform velocity motion because there is no force in the horizontal direction, divided by t1. So you'll get u0 cos theta. So the range for the second motion, if you call this as r2, because what you have to find is the average velocity between this point and the last point. That will be v average for the entire motion. That will be r1 plus r2 plus so on, divided by the total time taken, that's t1 plus t2 plus so on. So we have to find this r2, t2 and those things. So r2 is this range. So horizontal component of this velocity, that's u0 by alpha. Angle is same, cos theta, into the corresponding flight time t2. Okay, so t2 is, we can get from the vertical motion. T1 is, for the first part of the projectile motion, if you use this Vy equal to Uy minus G T1 by 2. The first part of the projectile motion, I'm using this point. Okay, so from here to the time is T1 by 2. So from this you get T1 as, and this one is 0 at this maximum height point. So from this I get T1 as Uy is U0 sin theta by G into 2. So the second one, the corresponding time is T2. That T2 again, I'll use the same equation at this point. So that will give me 0 equal to the second time the velocity will go by reduced by alpha into sine theta minus g into T2 by 2. At this point, the velocity is u naught by alpha. Y component is sine theta. Okay, so from this I'll get T2 as 2 u naught sine theta by g into alpha. So comparing with this, you get T1 by alpha. So the flight time T2 has gone down, has reduced with a shorter path by a factor 1 by alpha. Similarly, we get T3 as will become alpha square because that's how the motion is. Each time it rebounds, the velocity goes down by a factor 1 by alpha. So if we use that, T3 will be T1 by alpha square. So each time the flight time is getting reduced. T3 is less than T2 by a factor 1 by alpha. So this is how T1, T2, T3 varies. So in the range, R1 is u naught cos theta, the horizontal component of the velocity into the time T1. So R2 will be the horizontal component of the velocity is gone by a factor alpha cos theta, and the flight time T2 has gone down by a factor alpha. So T1 by alpha. So this is equal to, using this, the first one, we get R1 by alpha square. So the flight time has reduced by 1 by alpha in one step, but the range has reduced by 1 by alpha square. Similarly, R3 will be the horizontal component of the velocity here, that's u naught by alpha square cos theta into T3. T3 is T1 by alpha square. So it's R1 by alpha raised to the power 4. So each time the range goes down by a factor 1 by alpha square. The flight time goes down by a factor 1 by alpha. So with this, we can solve this question because what we have to find is this one, V average for the entire motion. Okay, so now R1 plus R2 plus R3, you can write it here itself. So V average for this entire motion, R1 plus R2 plus R3. So R1 I can take out commonly outside. It will become a sum of geometric series where the common ratio is 1 by alpha square. And it's an infinite series. And alpha is greater than 1 because it's given in the question. After hitting the ground, the ball rebounds with velocity. Speed is reduced by u naught by alpha. Speed is reduced by u naught by alpha means alpha has to be greater than 1. Only then there is a reduction in speed. So alpha is greater than 1. That means the common ratio, which is 1 by alpha square, is less than 1. That's a good thing to happen because infinite series, if the common ratio is less than 1, then the sum is convergent. And similarly here, T1 I can take commonly outside. T2 is 1 by alpha times T1 plus 1 by alpha square. Again, it's an infinite series. Okay, so here the common ratio is 1 by alpha square, here the common ratio is 1 by alpha. And since alpha is greater than 1, 1 by alpha is less than 1. So sum of infinite geometric series with a common ratio is less than 1 will be A by 1 minus R. So R1 by 1 minus R is 1 minus alpha square. Sorry, 1 by alpha square. Common ratio is 1 by alpha square. And the denominator is another GP. So A1 by 1 minus R, which is 1 by 1 by alpha. So this you have to simplify. So V average for the entire motion R1 by T1 into this will go up 1 by 1 minus alpha divided by 1 by 1 minus alpha square. So this A square, 1 is same as 1 square. So A square 1 is B square. So if you do that, you'll get R1 by T1 into 1 by 1 plus alpha. A plus B into A minus B. A minus B will cancel the numerator and A plus B is this one. And R1 by T1 is given as V1 in the question. So this is V1 into 1 by 1 plus alpha. And this also given in the question as 0.8 V1, the average velocity of the entire motion. Average velocity of the entire motion is 0.8 V1. So this is 0.8 V1. So I can take 1 by 1 plus alpha on the right side. 0.8 is 8 by 10. So if it goes to the right side, it will become 10 by 8. 10 by 8 is 1 plus 2 by 8. 2 by 8 is same as 1 by 4. So if you compare this one, we'll get alpha as 4. The question is to find alpha. It's a simple question but slightly lengthy. Four is the correct answer. This is what I explained here. So average velocity is total displacement, total time. That's the basic. And the average velocity of the first part. The projectile is like a repeated. So this one is the first part. This second part, third part, like that. So average velocity of the first part is the average velocity between this point and this point. So between these 2 points, the displacement is R1. And the time taken is T1, the flight time T1. Okay. And R1 is the horizontal component of velocity, that's U0 cos theta into the flight time T1 by T1. So it's U0 cos theta. And which is equal to V1 that they have mentioned in the question. So average velocity of the entire motion is the average velocity between these 2 points, this point and this last point here. It's an infinite motion. So but it will converge. So it's in somewhere here. So the total distance or the total displacement is R1 plus R2 plus R2 so on. Divided the total time is T1 plus T2 plus so on. So you have to find R2 and T2 in terms of T1. So the flight time, you have to take the maximum height point on the vertical motion, V equal to U plus AT, and A is minus G, and the time is T by 2 to go from ground to the maximum height point. So from this, you get the flight time as 2 times U0 by G into sine theta at the topmost point. And T2 will have, instead of U0, we have U0 by alpha because the velocity is dropping down by a factor 1 by alpha. Theta is same. So T2 will be T1 by alpha. Range is horizontal velocity, which is U0 cos theta at the time T1. So the second loop or the second part, the time is going down by a factor alpha. So T1 by alpha, and the velocity is only dropping by factor alpha. So this will be R1 by alpha square. So this we can extend. R3 will be R1 by alpha raised to the power 4, and T3 will be T1 by alpha square. So for the entire motion, the average velocity is total displacement is R1 plus R2, which is R1 by alpha square plus so on, and T1 plus T2, and T2 is T1 by alpha. Okay, so and R1 by T1 is V1, and say infinite geometric series. So the sum of this one is 1 divided by 1 minus alpha square, and sum of this one is 1 divided by 1 minus alpha, so this will go up. So simplifying, we get alpha as 4. It's a simple numerical manipulation which you should be able to do.